Okay, this one we are going to be working with something called opposite coefficients. And what I mean by that is I'm going to be looking to either to add up two coefficients that will cancel to 0. Now what I mean by that is, like, what's the opposite of 5x? Well, negative 5x. So if I were to add 5x and negative 5x, what would I get? I would get 0 x's, and the x times 0 is 0. Okay, so what is the opposite of 3x? Negative 3x. How about negative 2x? Positive 2x. So my goal always is to get these opposite coefficients. Now you will hear some people say that you can add or subtract, and it's true, but I like to just stick with add so that we don't get confused about distributing a negative. Sometimes people call this linear combinations, and they also call it elimination. So it depends on who's teaching the class or which publisher wrote the book. So I'm going to show you what I mean. So again, remember, systems, our whole goal is to find a problem where I get one x and one y preferably, and that would recognize a point. So if I look at this problem right here, I have a y and a negative y. Well, what number is in front of 1 and a negative 1 are both 1s. Well, what if I did 1 plus negative 1, and since they're both y's, what would happen? Well, this is what I'm telling you. They would cancel to a 0x. So the y variable, so I'm always looking to see if there's already opposite coefficients. It also doesn't matter if you get rid of your x's first or your y's first. But see here, the x has a 1 and then a 2. Well, look what happens. So what I'm going to do, it's very important before you start this, is that your equal signs are lined up, your y's are lined up, your x's, and your coefficients. You have to almost have them in columns. So now when I do this, if I add the two equations, x plus 2x, it's just like 1 plus 2, 3x. Okay, and 1y plus negative 1y is 0y. So that's just canceled out altogether to 0. Okay, and then 13 equals negative 7, or 13 plus negative 7 is 6. So now we can just divide, and when I divide, I'll divide by 3, and I'll have x equals 2. Okay, so now I have x equals 2. And again, we're always looking for those number answers, but we're going to plug it back in. Now, like in substitution, we had to plug it back into the one of the equations, but in this time, it really is your choice. So you can go back into any of them. You could go back into one of your originals, okay, which in this case, we didn't change any, but eventually you're going to find out that it doesn't matter if you go into originals or a newly created one. So in this one, I like to remember to put my parentheses around anything that I'm substituting in. So parentheses around my 2, and then I have plus, and I'm just looking at the first equation, x plus 1y equals 13. So x plus 1y, which I'm just going to keep the y, equals 13. Well, to get that y by itself, what do I have to do? Well, I'm just going to subtract the 2, and I'm left with y equals 11. Now, once I have an answer, a number answer, not an expression, for x and y, I can put it in my ordered pair again. So my final answer is 2, 11. Now, what that means also is if I were to put this on a graph, if I went over 2 and up 11, I would end up in that same spot. Now, what happens if you do not have opposite coefficients? Well, then you can be creative. And here's what you're going to do. Now, you're going to notice I have two different problems here, and I'm going to show you two different ways you could have done it. So the first time, I'm just going to cover up one of the sides here. Okay, so we're just going to work at one at a time, and then I'm going to show you how it wouldn't have mattered if somebody else did something else. So here when I look, I have 2 and negative 4x. I made sure everything's lined up, my equal sign, everything. And I look and I say, oh, well, 2 and negative 4x. Well, those aren't opposite. I remember opposites are if I had 2 and negative 2, 4 and negative 4, 3 and 5. They're not opposites. So what I'm going to do is I'm going to see if this is negative 4, what's opposite of negative 4 that would be the ideal opposite coefficient would be a positive 4. Well, if I'm allowed to multiply the entire equation as long as I do it to every single term by anything I want. Well, so I'm going to choose 2. And I'm going to do it just to the top equation. So my new top equation will be 2 times 2x, which is 4x, plus 2 times 3y, which is 6y, equals 2 times negative 6 is negative 12. Okay? So all I did is I distributed my 2 to everything in there. All right. Now, I still have the other one, which is the second equation, which was negative 4x plus 5y equals negative 21. And what I'm going to tell you with this, now we can add them because look at that cool thing I created. I created the negative coefficients, the opposite coefficients that I wanted. So again, last time we solved for y, but this time I'm getting rid of the x first, so that's okay. So that equals 0x. I get 11y equals negative 12 plus negative 21 is negative 33. Now again, if you're using a calculator, you'll hear me say this over and over in my videos. I call it touch math. If you're using a calculator, negative 12 minus 21. Even though we're adding, the way you would read it is minus. If you can touch a symbol or a number, you can push the button on the calculator. So I can touch a negative, a 1, a 2, a minus, a 2, and a 1. So 6 buttons is all I push. Do not add extra. Okay, finally, I'm going to divide both by 11. And I have y equals negative 3. All right, so I have one number answer for a letter, but I still need to know what x is. So I have to go back in and figure out what the x is. Now, I can plug it into my 4x plus 6y is negative 12. I can put it into negative 4x plus 5y equals negative 21. Or I can go up to one of my originals with 2x plus 3y equals negative 6. So that doesn't matter. So if I do that, and that's what I'm going to do, I'm just going to go ahead and put it in my very original. So 2x, make sure I don't put that negative 3 in for the x because I want it to go in for the y. The original problem was 2x plus 3y, so instead of y, I'm going to use negative 3 equals negative 6. When I put that together, I have 2x, 3 times negative 3, that's negative 9, equals negative 6. Now, I'm going to put this, and I finish the problem on the variable side. So when I do that, I'm going to add 9. That leaves me with 2x equals negative 6 plus 9 is 3. Okay? Now, this one doesn't come out as nice as I had hoped it would, but it's just the way it is. Sometimes when you're into the math, the answers don't come out nice. So this is x equals, now 3 over 2 can be written as, we can leave it as 3 over 2, which is typically what most of your math teachers are going to want. You can turn this one into a decimal because 2 goes in one time with 1 left over. And 1/2 is actually a nice terminating decimal like 1.5. Now I'm a stickler that if it doesn't come out to a terminating decimal, I'd rather you leave it in a fraction form because then we're working with approximate instead of exact. Okay, so my final answer here is 1.5 comma negative 3. Do you see how I wrote it? All right, now I'm going to do the exact same problem, but this time I'm going to switch out what I do. So now I'm going to hold up the other side. So again, same problem with the lack of coefficients. But this time, maybe I didn't notice that I could multiply the top by 2 to make that 4. Instead, I said, well, this is 5, and this is 3, If I multiply the top one by 5, my y will be 15y. And then I have to multiply the bottom by -3 so that my other y will be the opposite y of -15. And again, I'm allowed to multiply by whatever I want as long as I do it to every single part of the problem. So the first part would turn into 10x plus 15y equals -30. The second one, -3 times -4, would be 12x minus 15y equals positive 63. Now, look where those nice little opposite coefficients show up, right there. And notice I'm circling them. What number does it kind of look like that circle is? A 0, because it's 0y. So that's why I like to do it like that. Now I add the other two, so that's 22x equals, now -30 plus 63 is 33. And when I divide by 22, ooh, it's looking kind of ugly, isn't it? But guess what? If I do this, I have 33 over 22. That's one thing. I can divide them both by 11 to reduce and be 3 over 2. Oh, that looks an awful lot like my other equation, doesn't it? And then you could also turn that to 1.5 or 1.5. Doesn't matter. Well, now I got to plug it back into one of the original problems. So this is why I personally like to leave it in fraction form, but most of my students hate fraction form. So if I do 3 over 2 for my x, and I'm just going to plug this right in to my very original problem, 2x. So I have 2 times 3 over 2 plus 3y equals -6. So all I changed from the original problem was what my x was. See my x right there? Okay, when I multiply 2 times 3 over 2, it's 6 over 2. Remember, bottoms of fractions only multiply with other bottoms of fractions. Plus 3y equals -6. Well, look at that. 6 divided by 2 is 3, so let's clean that up. And now I can subtract 3. I have 3y, and again, touch math, -6 minus 3, -9. Divide by 3, y equals -3. So, my answer again is 1.5, comma, -3. Does that look familiar? It sure does. It should, at least. So this is one of those problems that you can just do, and you just are creative with these, okay? We'll have another video eventually where I can show you how to eliminate fractions if you need to. Okay? Thank you.